Morning. This is a maths tutorial based at question 7 from the AS Pure 1 paper from May 2018, looking at trigonometric ratios. So, question 7. We're told in a triangle ABC, AB has length 10 centimetres, side AC has length 5 centimetres, and the angle BAC is theta. It's unknown at the moment, but what we do know is that theta is measured in degrees. And we have this additional piece of information: the area of triangle ABC is 15 centimetres squared. So part A, we're told to find the two possible values of cos theta. Well, first and foremost, if we're given information like this and it's based around geometry, what we need to do is draw a picture of what's going on. So as a rough sketch, I'll draw this. And I'm going to label it A, B, C. We know that side AB has length 10 centimetres, AC has length 5 centimetres, and angle BAC is theta. So, we're given this crucial piece of information at the end. The area of ABC is 15. So we know the area is 15. But for a non-right angled triangle, we need to remember that the area of it is a half AB sine C. So we have two side lengths. We have the angle subtended between the two side lengths that we know, and we have the area. So let's go somewhere with that and see what happens. So I have my 15 is equal to a half times 5 times 10 times sine of theta. So if I rearrange this, I actually get that sine theta is equal to 15 over 25. Now I'm going to simplify that a bit, which gives me 3 over 5. But thinking about the question, it says find the two possible values of cos theta. Well, here I seem to have sine theta. So I need to think actually about a trigonometric identity here that could link sine theta and cos theta. Well, the one that you will already know is in fact that the sine squared of theta plus cos squared theta must equal 1. Now, I know sine theta, 1's already given, and cos squared theta is what I'm going to find out. Now, this is interesting because the question says find the two possible values of cos theta. So I would say we're on the right lines, because if we square root anything, we get two possible values, the plus and minus of the root. And we'll have that because we've got cos squared and we want cos theta. So let's substitute into this identity here. So I have sine theta, but it's squared, plus cosine squared theta equals 1. Now from there I'm going to rearrange, and I have that cosine squared is equal to 1 minus 9 over 25. So all I've done is take the 3 over 5 squared and move it over the equal sign. However, yes, I have cos squared theta, but the question says I want the two values of cos theta. So to get cos theta from cos squared theta, I'm going to square root both sides. So I get that cos theta is equal to plus or minus. Don't forget, if we square root anything, it's plus or minus. 1 minus 9 over 25 is indeed the the square root of 16 over 25. So in fact here, cos theta is equal to plus or minus 4 over 5. So for this question, it was worth 4 marks in total. You would have gained 1 mark for using the area, another mark for finding that sine theta was 3 over 5, 1 mark for recognising you'd need to use the identity between sine and cos, and 1 mark for getting the final answer. Now, part B is quite an interesting question. So I'm told from my triangle that I need to find the exact length of BC, given that BC is the longest side of the triangle. Now, from this, we need to think about the language of the question. You should remember from GCSE that exact means that we want no decimals, but we want surds or whole numbers. So if your answer comes out as a decimal and you don't have a whole number or a surd somewhere, that's a time to review what we've done. So if I want to find the exact length of BC, I'm going to call it x. I have 2 sides of the triangle, and from the ratios and the other question of sine and cos, I know that cos theta is plus or minus 4 over 5. So I do actually have a value for this angle in terms of cosine. So I'm going to use the cosine rule, which you should know is a squared is b squared plus c squared minus 2bc cosine of a. Now this will differ depending on how you've labelled your triangle. Thankfully, it's the same here in this situation as the standard formula. So we're going to find that x squared is equal to b squared, which would be 5 squared, plus 10 squared, minus 2 times 5 times 10 times cosine theta. This is the interesting part though, because from part A, we found that cosine theta has 2 values. It has positive 4 over 5 and it has negative 4 over 5. So what we need to do here is substitute each value for cosine theta, and we want to find the biggest side. So we need the value of cosine theta, which will make x bigger than both 5 and 10. So for the first case, I'm going to let cosine theta equal positive 4 over 5. Then x squared will equal 25 plus 100 minus 2 times 5 times 10 multiplied by 4 over 5. Now, if we compute this, I find that x squared is 45, and then x would be the square root of 45, which is 3 root 5 when simplified. Now, yes, that's in an exact form, but the issue is 3 root 5, yes, is bigger than 5, but it's not bigger than 10. So this is not the case we want to use. But case 2, let cosine theta equal minus 4 over 5. Then I have x squared is equal to 25 plus 100 minus 2 times 5 times 10 times minus 4 over 5. And this gives me that x squared is equal to 205. So x would be the square root of 205. Is this in an exact form? Yes. Is it bigger than both 5 and 10? Yes. So we have fulfilled the requirements of the question. So the exact length of BC is root 205 centimetres. And that's for a further 2 marks and a 6-mark question overall.